This is a video on how to solve mixture problems. Before we begin talking about mixture problems, we really should talk about the formula where the rate times the amount equals cost. And this is something you probably use in your everyday life. It's not something that's very uncommon. You just might not talk about it this way. If you go to the grocery store and you're purchasing something, it usually costs a certain rate, either a price per item or a price per pound, times the amount of that item you're purchasing will equal the total cost of that item. And for short, we'll say R times A equals C. Some people will remember this as just RAC, is one way to remember that. But R times A equals C. So let's take a look at an example here. It says the price of chicken is $3.27 per pound. What is your total cost if you buy 15 pounds of chicken? So we're looking for total cost. We're looking for cost in our formula. And remember, the formula we're going to use is the rate, times the amount is equal to the cost. And when you're looking for the rate in the word problem, the word per generally signifies the rate. So this is the price per pound. So that's the rate we're going to use. We're going to use 3.27 for the $3.27 per pound. Times the amount, alright, so the amount of the item we purchased 15 pounds of chicken, so it's going to be times 15, and that'll be equal to our cost. So basically we just have to multiply these together, 327 times 15, and that equals 49.05, and that's in dollars, because remember this is our cost. So our total cost to purchase this chicken would be $49.05. Now, when we're going to use this formula, we're not going to have just a basic example where we're trying to just find the cost of an item multiplied by the amount of the item. We're generally going to have two items being mixed together, and we're going to try to figure out how much of each item do we need. So that's what we're going to talk about mixture problems. So we're going to be mixing two items, and we're going to try to find the amount of each of them that we need. Let's take a look at an example. So a grocery store wants to create a candy mixture containing both M&Ms and Reese's Pieces. If M&Ms sell for $1.60 per pound and Reese's Pieces sell for $2.40 per pound, how many pounds of each type of candy should be used to create a 20-pound mixture that costs $2.08 per pound? Now there's a lot of information here in this word problem. I like to start off by thinking of, how many things am I looking for? And in this case, the question here, it says how many pounds of each type of candy. So I'm looking for two things, because there's two types of candy. I'm looking for how many pounds of each type of candy should be used to create a 20-pound mixture. So that means I'm going to need two let statements. And let's start by letting x equal, in this case you could pick either one, the pounds of M&Ms or the number of pounds of Reese's Pieces. It doesn't matter because they didn't give us more information about one or the other. But we do need to know how many pounds of each, so we have to have let statements for each. I'm going to let x equal the number of pounds of M&Ms. And if x is the number of pounds of M&Ms, and we need a 20-pound mixture total, then our let statement for the Reese's Pieces should be 20, the total weight, minus x, the number of pounds that we used for M&Ms. And that'll give us the number of pounds of the Reese's Pieces. Alright, now, anytime you have a problem where you're splitting a quantity into two, you're always going to let x be the first part, and then the total minus x be the second part. In this case, it's just like if I have 20-pound mixture. If I gave x number of pounds as the first part, 20 minus x is what's going to give you what's left over. Alright, so you're subtracting it away from the total. Now that I have my two let statements, I'm going to set up a chart here. And I'm going to use that formula that we're talking about, the rate times the amount equals cost. Because if I can figure out the cost of each of the M&Ms and the Reese's Pieces, I can set it equal to the total cost. So in this chart, I'm going to have three columns. We're going to have the rate, the amount, and the cost. And I'm going to have rows that are labeled with M&Ms, Reese's Pieces, and we'll also have a row for the mixture. And we're just going to fill in this chart for now. So for the M&Ms, the rate for the M&Ms, well, M&Ms sell for $1.60 per pound. Remember the word per in there is just telling you that's the rate. So the rate for the M&Ms will be 1.60. The amount of M&Ms, meaning the number of pounds of M&Ms that we have, well, we don't know. That's what we're trying to find, right? We're trying to find how many pounds of each type of candy. So the pounds of M&Ms, we called it X. It comes from your let statement. All right, so X is the number of pounds of M&Ms. That's the amount we have. So to find the cost, $1.60, 1.60 times X, right? The rate times the amount will give us the cost. So 1.60 X is what we're going to use for the cost. So this gives us the cost of the M&Ms. That's what we're really doing when we're filling out this chart. We're finding the cost for each piece. So the cost of the M&Ms will be $1.60x. For the Reese's Pieces, the rate is going to be $2.40 per pound. All right, so it's telling you that's the rate there. All right, the amount of them we have, well, that comes from our let statements, right? We're looking for that. It's going to be 20 minus x. And the cost, well, rate times amount gives us cost, so this is going to be 2.40 times 20 minus x. And notice I have the parentheses there. If you know the parentheses, you're going to forget to distribute through. So it's 2.40 times that whole 20 minus x. You need parentheses there. And then for the mixture, the rate of the mixture is $2.08 per pound, so this will be 2.08. All right, times the amount. All right, well, how many pounds is the mixture? The mixture is 20 pounds total. All right, we know that, so this will be times 20. And then we're just going to do 2.8 times 20, and that comes to 41.60. This gives us the cost of the mixture. So we know the total mixture is going to cost $41.60. So now that I know the cost of the M&Ms and the cost of the Reese's Pieces, if I add those together, that should equal the total cost for the mixture, and that's how we're going to get our equation. So our equation should be the cost for the M&Ms, $1.60x, plus the $2.40 times 20 minus x, the cost of the Reese's Pieces, will equal the total cost, which is the $41.60. And we'll do this equation on the next page. Alright, so here's our equation. 1.60x plus 2.40 times 20 minus x equals $41.60, or 41.60. Alright, so just adding up the cost of each, M&Ms plus the cost of the Reese's Pieces equals total cost. And now we solve like normal. So the first thing we want to do here is distribute. So we're going to have 1.60x, that doesn't get affected. And then we're distributing a positive 2.40. So a positive 2.40 times 20, right, comes to a positive 48. And then 2.40 times a negative x makes that a negative 2.40x equals 41.60. Alright, and make sure you don't lose that negative sign there when you multiply a positive times a negative here. It's going to be a negative 2.40x. Once we're here, we're going to combine like terms. So we're going to combine the 1.60x and the negative 2.40x. Alright, and 1.60x minus 2.40x gives us a negative, and the sign is important here. It gives us a negative 0.80x plus 48 equals 41.60. Alright, and now solving like normal, we're going to isolate our variables on one side of the equation, so we're going to subtract 48 from each side. Subtract 48. These cancel, and you're left with negative 0.80x is equal to 41.60 minus 48, which gives us a negative 6.4. And to solve for x, we're going to divide by a negative 0.80. Divide by a negative 0.80. These cancel out. We're left with x is equal to. Now a negative over a negative is going to give us a positive. And remember, we have to get a positive number. We're talking about the number of pounds of candy. So a negative over a negative is going to give us a positive. And then 6.4 divided by 0.80 gives us 8. Now when I say x equals 8, 8 is the number of pounds of M&Ms. Remember, this comes from our let statement. Alright, when I'm solving for x, taking a look back at our let statement, x is the number of pounds of M&Ms. So make sure you have units on here, and make sure you know what you solve for. So x is equal to 8 pounds of M&Ms. And remember that you need the number of pounds of each, right? The question asks for both. If you don't answer both, you're not going to get full credit. So x equals 8 pounds of M&Ms. 20 minus x, coming from our let statement back here, is equal to the number of pounds of Reese's Pieces. So to find that, we're going to do 20 minus x, which is 20 minus 8. So that equals That's 12 pounds of the Reese's Pieces. And then we found both. We found the amount of each that we would need. Alright, here's an example for you to try on your own.